My name is MUS. I will be discussing how I could catch on to 12 sectional sectional which easily with the hope that other students may stop having nightmares nightmares about the 14 music theory for class. In fact, many of my friends come directly from the textbook. Please read my background information in the slide. I will now turn the text over to my net lecture and the Mark Mustard.
Hello, everyone. Mark Music. I'm Cindy's narrator. She said, why is Cindy presenting 12-tone serialism? She appreciates the relationship between math and music within the process of serialism. She found that many of her classmates in Music Theory 4 were confused about serialism. She was confused too, but her mentor and facilitator understood it and guided her learning. I used to teach math, and Evan was a band director. And Cindy also enjoys helping people understand different things. Okay, the piano keyboard and the octave. I'm sure everybody is familiar with what the piano keyboard looks like. Cindy put a keyboard together along with the notes, and you can see that the notes repeat every octave. The names of the notes repeat every octave. Okay, Cindy pointed out two. Remember the circle of fifths? That also repeats. So, what exactly is 12-tone serialism? Cindy presented some slides that will help in these four categories. So, what is the definition of 12-tone serialism? As you can see on the slide, 12-tone serialism is a method of composition designed to methodically equalize all 12 pitch classes. Just very briefly, a pitch class is every note that has the same name. For instance, all C's belong to the C pitch class, no matter what octave. Each work or piece is based on a pre-compositional series or role, and no pitch class may be repeated, with minor exceptions, until all 12 pitch classes have been sounded. And that came from the Cindy's Music Theory textbook, which I believe you still work out of. What significance does serialism hold in music history? Cindy notes that it's the next logical step from the late Romantic styles of Strauss, Mahler, and Brahms. Use developing variation, which is a process of continually building on germinal ideas or motifs, so that each new idea is derived from what has come before. Use non-repetition, a process whereby nothing repeats exactly, except for marked repeats in binary forms. And these carry forward the prior principles in a new manner. and that's from the music history book that Cindy had. Okay, here are the three major composers of 12-tone serialism: Arnold Schoenberg, Alban Berg, and Anton Webern. So Arnold Schoenberg was the teacher of Berg and Webern. Here's an example of 12-tone serialism from Arnold Schoenberg's Piano Suite, Opus 25. I'll play an excerpt of that very shortly. This is the prelude. The Gavotte. As Cindy says, it's a very nice tune to dance to. Notice, even though it's a new approach to using notes, it still use some of the older forms. Okay, now it repeats back to the beginning, back to the A section. Okay, let's go on now. As Cindy warned you before, she has earned a math minor, and I am a former math teacher, so let's do some review of modular arithmetic. We'll be talking first about base 10, then mod 10, mod 3, and mod 12, and I'll explain why Cindy chose those as we go through. Our familiar base 10 system uses the 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We use base 10 in everyday life, and as we write numbers, place values denote powers of 10. So 342 means 3 hundreds plus 4 tens plus 2 ones, or 3 times 10 to the second power plus 4 times 10 to the first power plus 2 times 10 to the 0 power. And if you now have a number like 3.42, that means 3 ones plus 4 tenths plus 2 hundredths, or 3 times 10 to the 0 plus 4 times 10 to the negative 1 power plus 2 times 10 to the negative 2 power. And most of us have used a somewhat familiar mod 10 system without actually thinking about it too much. We use the digits 0 through 9 again, but in repetition, such as octaves in the piano, we have the 12 notes that repeat. Okay, when adding numbers, move clockwise. So most people would know that 7 plus 2 is 9. However, if we go 5 plus 9, so we go clockwise 9, that's 4, 5, 6, 7, 8, 9, we end up at 4. So 5 plus 9 equals 4 in the mod 10 system. Similarly, if we subtract numbers, instead of going clockwise, we'll go counterclockwise. So if we have 7 minus 2, start with 7, go counterclockwise 2, we end up with 5. So nothing strange there. But 5 minus 9, if we start with 5 and we go clockwise 9 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, we end up at 6. So 5 minus 9 equals 6. Okay, we can do the same thing with a system that involves only 3 digits. 0, 1, and 2 would be mod 3. Again, adding, we will move clockwise. So 1 plus 2. So you start from 1, go clockwise 2 places, you end up at 0. Now 2 plus 2, you start on the 2, you go 1, 2, 2 plus 2 equals 1. Okay, and then let's look at 1 minus 2, because that's a fun one. So 1 minus 2 is 2 in mod 3, and 2 minus 2 is 0. So let's look at one more system. Okay, mod 12. There's a specific reason why Cindy wanted mod 12 explained, but to just have a little background in modular arithmetic, so it makes it a little easier. It's the same type of thing now. For mod 12, we have the 10 numbers, 10 digits, 0 through 9, and we have 2 more digits. Let's call them alpha and beta for now. So we have 12 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, alpha and beta, which is this set right here. So when adding numbers, move clockwise again. So if we have 7 plus 4, 1, 2, 3, 4, 7 plus 4 is beta. 5 plus 9, so 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 plus 9 is 2 in mod 12. So likewise with subtraction, after I get rid of this, okay, so let's see, 7 minus 2 is 7, minus 2 is 5, that's not very strange. How about 5 minus 9? So we start there, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 minus 9 equals 8. Okay, here's the reason that Cindy wanted to use mod 12. The chromatic scale and mod 12 are both systems that use 12 notes for chromatic scale or digits for mod 12 within the sequence before they repeat. Okay, this is a way that Cindy creates a melody or a prime theme when she used serialism as the basis of her compositions. So first, before we go into that, we'll talk a little more detail about the pitch class, the general rules of using serialism, how to create the prime theme using the rules, and then a substitution for numbers in place, using numbers in place of note letters. Okay, what is a pitch class? We talked about that a little bit before. So a pitch class is the set of all notes of the same name that are available for that composition. For example, all of the notes named C, no matter which octave, belong to the same pitch class, namely the C pitch class. Similarly, it follows that all of the F sharps and G flats belong to that same F sharp G flat pitch class. Note that chromatic or enharmonic spellings are irrelevant. They belong to the same pitch class. Okay, what are the rules or guidelines for creating the prime theme or a series or a row, as the terms are used somewhat interchangeably? Base the prime theme on a pre-compositional ordering of the 12 pitch classes that is determined by the composer. This ordering is also called a series or row, which I alluded to. No pitch class may be used again until all other pitch classes have sounded. However, a pitch class may be repeated as consecutive notes, trills, tremolos, pedal points, and other musical figures. The row is used to give an order to the composition, and those points come directly out of the music theory book, I believe. Here's a process that Cindy has used in creating 12-tone compositions. So cut a piece of paper, of scrap paper, into 12 1-inch squares. Doesn't have to be exactly that amount, but just 12 small pieces that are big enough though to write one name of each of the 12 pitch classes on each of the 12 squares. Place all the squares in a bowl. Randomly draw one square at a time until all are drawn, and that gives you the order of the pitch classes in your row or series. Write out the notes. You now have your series. There's one last thing I wanted to mention on the last slide, that there are many other advanced methods that can be studied in advanced composition books about how to put a series together. Another method that Cindy came across is to use a dodecahedron dice, which is a 12-sided figure that has the 12 notes in. Just roll it, and if you write down the note if you haven't had it before, and keep going that process until you get all 12 classes. Okay, now how to substitute numbers for note names. Cindy recommends using the chromatic scale based on the first note of the primary theme of the work, and we can use the mod 12 slide for the proper sequence. So that was the one with 0 at the top going around through 9, and then you have the alpha and beta. So you had 0 on top, going around the 6 on the bottom. Let's just put that down to just recall basically. Then you had the alpha and the beta. Okay, so that's basically what it looks like. Okay, so assume the primary theme begins on D flat, then you can use this substitution if you're going to base it on the chromatic scale, the first note of the primary theme. So if you have D flat, then set that equal to 0. D is 1/2 step above D flat. E flat is 2/2 steps above. E is 3/2 steps above. F is 4. G flat 5, G6, A flat 7, A8, B flat 9, B natural would be your alpha, and C would be your beta. Okay, another example, if it begins on G, then G equals 0, G sharp 1, A 2, A sharp 3, etc., all the way through F equals alpha and F sharp equals beta. This is the series that Cindy randomly created using the pull the paper out of the hat trick. So note that the numbers also A equals alpha equals 10 and B equals beta equals 11 per the substitution that she described in the prior slide. So here, because alpha and beta were kind of tough to get, Cindy used a B in place of the beta, or you can also use an 11 in place. For the alpha, the alpha or 10 may be a useful substitution also. So the Roshi formed B flat, E flat, D, F, G flat, E, A, D flat, C, A flat, and G is hiding a little bit. So that's the series that Cindy created. The next step in writing serial music is to rewrite the prime theme P as its inversion, its retrograde inversion, as well as doing all 12 transpositions of each of the 4 forms. Therefore, you end up with 48 different variations. And I'll explain how to do these shortly. Okay, now how do you find the inversion of the prime theme? So you've written out the prime theme already. Then you reflect or invert the interval made from the first note to the note that needs to be reflected and continue until all notes are reflected. So the first note, if you reflect across the first note, your first note's inversion is always the first note. That does not change. The second note, we had a B flat, which enharmonically is an A sharp. So an A sharp is a minor second below B. So its inversion is a minor second above B, which is C. Likewise, the third note was an E flat or enharmonically a D sharp. A D sharp is a major third above a B. So the inversion of the D sharp would be a major third below, which is a G. So likewise, you can keep going like that. However, if all your notes are assigned numbers with the first note assigned 0 and the other notes assigned chromatically, like was discussed earlier, the inversion of that note in the pitch is a class directly opposite with respect to the vertical line between 0 and 6 of the original pitch class. So let's look at the next slide and we'll go into that detail a little bit more. Okay, here's the mod 12 slide. So we said in the prior one, we can draw the vertical line connecting 0 and 6, and you can draw horizontal lines. It turns out that 0 is its own inversion, 6 is its own inversion, and 7 and 5 are inversions of each other, 8 and 4, 9 and 3, alpha 10 or A, and beta 11 or B and 1. So those give you your reflection pairs or inversion pairs. And if you notice too, if you add the corresponding numbers, let's put 11 in for beta and 10 in for alpha. The total of each inversion set is the same number. And how does that compare to the mod that we're using? Quite similar. The only exception to that rule is 0 is its own reflection or inversion. And that is a case that you just know that if you're starting off with a 0, it will have to be its, and you're reflecting across 0, it will be its own reflection or inversion automatically. The next thing we'll look for is the retrograde of the prime theme. We wrote out the prime theme before, and we're going to write it backwards. So it's cut off a little bit here, but B was the first note in the original theme, so B will be the last note in the retrograde. Likewise, in the original, G was the last note of the prime theme, therefore G will be the first note in the retrograde. So retrograde just means, again, writing it backwards. So this is exactly that's exactly what was written, only starting with the last note to the second last to the third last, etc. through the first, so until you get all 12 notes down. There are two ways of getting the retrograde inversion of the prime theme. I'm just Cindy only wanted me to talk about the easiest way. So you already have the inversion down. So just write the inversion backwards, and that will be the retrograde inversion. So in your inversion, we had B was the first note, so B will now be the last note. And E flat was the last note of the inversion. So for the retrograde inversion, we're going to take the E flat first, and then do the second last note of the inversion, third last, fourth last, etc., all the way to the B, which is first. Okay, please take the time to click this tab. Then you can hear how the 4 different forms, the prime, the inversion, the retrograde, and the retrograde inversion sound. So just click that speaker icon. Thank you. As Cindy alluded to earlier, the prime inversion, retrograde, and retrograde inversion can all be transposed. All four can be transposed into all 12 keys or starting notes. Completing the matrix, which will be described next, is the best tool in order to create these 48 combinations. In order to create the matrix, it's easiest to follow these steps. Use numerics first. Use the numeric substitutions for pitch classes that were discussed earlier, but it's also possible to use note names. Cindy, as mentioned earlier, likes to use a chromatic substitution with 0 as the first pitch class. Form a 12 by 12 matrix. Spreadsheet program works well for that. Fill in the top row with the prime theme and the left column with the inversion. Then fill in the remaining 120 squares by adding the number in the top row to the number in the left column using the mod 12 rules. So when you're done, actually it's the top row right to left is the retrograde, and the left column is the retrograde inversion. And now for the dreaded matrix, although it's not really that bad. So here is the 12 by 12 matrix that Cindy wanted me to refer to. So we have the original theme with numbers, 0, 11, which was beta, 4, 3, 6, 7, 5, 10, which is alpha, 2, 1, 9, 8. So, and if you go backwards, that's the retrograde. Going down is the inversion, 0, 1, 8, 9, 6, 5, 7, 2, alpha, beta, 3, 4. So that's the inversion, and the retrograde inversion is going up. Notice the main diagonal. If you use 0 as your first note, when you put your matrix together, it all equals 0. So, and to get each element, 11 plus 1 is 0 using that mod 12 circle. 4 plus 6 is 10. 7 plus 10 is 5. So those numbers all work out. So what you do again to get any of these elements, you go up and you go left to that element, add the numbers, and then it gives it to you. Add them, use the addition, of course, that we talked about earlier, the mod 12. And this is a conversion table putting letter names in. So if you remember, 0 was B, 11 was 11 or beta was B flat, etc. And if you notice the diagonal again, they're all B's, which is the first. Okay, now how to use the matrix to write an excerpt. Take one of the 48 12-note sets of pitch classes and put it into music. Continue the process until all 48 have been used. So identifying the transpositions. Okay, you recall that there were that the 12 by 12 matrix had all the notes in, and there were title rows and columns along the four sides. So that's what Cindy means by identifying the transposition. So use P. There we go. So use the P's going across. Identified. So if the first one number was a 4, that would be P4. If the number of the first note was a 4. Okay, so inversions, we're going vertical. So your inversions are here. So if your first note of your inversion was 5, you would name it I5. And then likewise with retrograde going off to the left, and your retrograde inversion going up. Please take some time to listen to Cindy's example that she put together. I don't remember offhand how many parts that she put in, but there were at least 6 of them, and a full piece would include all 48. They are identified. So it starts off with that one. I can't see which ones in particular were used. But yes, please take some time. They are identified. It's kind of like a Bach prelude type sound using 12-tone. Very interesting example. So again, please click on the speaker to listen. It's take about 1 minute to listen to it. It's really great. Okay, there's other ways to use serialism. Dynamics is one fairly common way. You could take a set of dynamics such as these 7. You could form, let's see, 7 times 4 is 28 different combinations using the 12-tone rules. So you could use that in concert with the 12-tone, but you'd have to go through it 5, actually into the 6th time. Let's cross that number out. It should be 6th. Okay. And likewise, if you have a set of 5 for duration, 5 different durations like half, eighth, dotted, quarter, quarter, and there you could choose to invert around the quarter arbitrarily. In this case, you'd have 20 possible combinations, so that actually gets into the 8th time. Okay, less common ways. Cindy's not familiar with any, but I'm sure they exist. An integral serialism for nice calculus word. It's using two or more types of serialism simultaneously, such as with dynamics in the 12-tone serial that we talked about earlier. And you could actually do all 3 of them between dynamics, duration, and the 12-tone rule, and you have a lot of fun with that. Cindy would like to take any questions that you have about the 12-tone serialism. And she has on the next slide, I have the last slide. Cindy put down her reference material. So go ahead, Cindy, finish up, please.
Thank you for taking your time to watch my presentation. I hope it helped take some of the mathematical mystery out of 12-tone serialism. Have a great day.
Goodbye.
Goodbye.
And here are the main sources that Cindy used. Thank you and have a great day. Goodbye.